Now let me give you an example of this. Suppose we look at a drawing I will do over here. And suppose you're a 2-year-old child, and I ask you, Susie, what do you see here? And you will say, of course, that you see a horse. And so you learn the word horsey. And we might look at a number of other horses. So I'll draw them as well. My years of art school training are paying off here. And there's another one. Okay. And then by contrast, say there's another little animal here that is much smaller and it's got pointy ears. Okay. And I say, what's that, Susie? You said that's horse. What's this? Well, that's also horse. What's this, Susie? That's also horse. And you say, what's that? Well, that's not horse. That's dog. Right? And so this, Susie can then see the difference between the dog and the horses, and we put all of those in one category, and then we come to understand horse. So we have a slightly more abstract concept here of horse, and we've distinguished that from the concept of dog, and also using our senses, we can see the differences between the horses and the dogs in this case. All right, suppose then we are carrying on teaching Susie her word lessons, trying to expand her vocabulary and understanding of the world. So we go for a walk in the woods, and we look at some of these objects. Right? And we say, what is that, Susie? And she says, well, that's a tree, right? And so we taught her the concept of tree, some kind of conifer there. And we draw some more here. So we look at that one. There's another tree, and there's another tree, and so forth. And then there might be, but say by contrast, some little tiny thing down the bottom, that we're looking at as we're walking along here, and we say that's a flower of some sort or other. So we put all of these in a category, and Susie assigns the abstract word designator word tree for that. And so now she knows tree, she knows flower, she knows dog, she knows horse, right, and so forth. Okay, then we ask Susie to perform a bigger abstraction. So far we're using our senses, and we're doing a little bit of rational categorization as well. We say, all right, Susie, what does this have in common with this? Suppose we now have these on a board, as I have, or in a picture here. What do they have in common? What are they both? And maybe we'll even give her one other set of categories over here. Suppose I draw some shapes on the board here, just some asterisks, and I say, what are all of those things? Well, those are asterisks, say, in contrast to this, which is just a square. But then I say, Susie, this, and this, what do those all have in common? And then we might draw her attention to 1, 2, 3, right? 1, 2, 3. 1, 2, 3. We're trying to teach her some numerical concepts. Then at a certain point, she says, oh, that's 3 trees, that's 3 horses, that's 3 asterisks. These are all 3. Okay, good. Now what have we done here? Well, we have now introduced a new abstract symbol, right? This stands for anything, right, that has 3-ness. It can stand for this, it can stand for this, it can stand for this in an open-ended kind of way, even though asterisks, horses, and trees are all very different in all of their particular dimensions. Nonetheless, they share something abstract in common. They share 3-ness, right, with each other. Okay, Susie is now 5 years old. Suppose we have got basic numbers under our belt, and we want Susie to start doing more difficult things. So we have done this with Susie. We've got 3, and now I'm adding this to, count them with me, Susie, 1, 2, 3, 4. I've done 4, right, more stars. So I had 3 stars. I added 4 stars. I use that symbol for that. So 3, 4. How many stars do we have altogether here, Susie? And then Susie at a certain point learns, that's 7. Now what we have now here is a completely abstract formula. Right? This is an abstraction, this is an abstract operator, this is an abstraction, this is an abstract operator, this is another numerical abstraction, and Susie gets it. And then at a certain point, she should be able, for example, even without counting on her fingers, even without having diagrams, be able to take abstract numerical concepts and manipulate them in her reason. And then at a certain point, Susie now gets into to middle school, and we're asking Susie to do things like, well, suppose you have 5, Susie, and you want to get 12, right? You need to add how much? And so we'll put an x in there. So 5 plus x equals 12. Solve for x, please, Susie. But now notice what we've introduced here. We've introduced an x, which is a variable, and then a variable in this context is an abstraction on any number, right? It can stand for any number, right, whatsoever. And after we get Susie comfortable with doing these sorts of things, she probably now wants to be called Susan rather than Susie. We then are going to start teaching her things like x squared plus y squared equals z squared. Right? We might teach her the Pythagorean theorem, right, for example, and teach her this formula here. But what do we have up here? We don't have any digits at all. Instead, it's entirely variables plus exponents, and we want her to be able to do that sort of thing in a manipulative fashion. Now let me grab another color here and just point out why, from the idealist perspective, this is a beautiful thing. What we are doing in this case here is starting when Susie is very young cognitively at the level of concretes, right, at the level of particulars, at the level of things that are physical, right, dogs, trees, horses, and so forth. And then what we're doing with Susie is taking her up the chain of being to a realm that is now abstract, purely mental, right, when we are doing these operations, right, in our head, and completely general, right, or generic. At this level of Susie's cognitive operation, she is primarily using her senses. She is a sensorially driven being. At this point, she is now a mature thinker, a human thinker. She's using reason and a pure reason. And it's a pure reason because on the idealist account, by the time you start doing higher order mathematics like this, you don't need the sensory inputs anymore. You can purify your thought from any sort of physicalistic understanding and consider the mathematical truths for what they are in their own rights. Also, what's true is these things come and go, right? The horses and the trees, right, and so forth, but 3 plus 4 remains the same. So those particular things in nature are all subject to change. Nonetheless, the higher truth, 3 plus 4 equals 7, that's eternally true. The Pythagorean theorem was true back when Pythagoras discovered it. It was true before he discovered it, according to the idealists. It still is true, and it will always be true in its exact perfect formulation as handed down through all of time.